Hello, everyone, and welcome at our bi-weekly core protocol sync. GitHub is finally working again, so we were able to finish our pull requests and ready to share updates. Shamil, you are the first one as usual. What was
Yeah,
happening on your side?
last couple of weeks I worked on the numerous PRs, mostly some minor tweaks for networking. Let me show my screen. So there are multiple tasks. This one shows some adjustments for timeouts for query and requests. There were also modification for warnings. I introduced some attempts for failed pieces requests. It's expected to have some failed attempts on the node startup or farmer startup. This is why I disabled the first couple of them. Also, we introduced several connection limits. It's this one and this one. This connection limit that we used on the lead P2P configuration, we used it as our manual setting with peer disconnection, and we changed that to use embedded connection limits into the P2P. It should decrease weird errors like YAML socket, etc. Socket connections failed. Also, we introduced some persistence for known addresses. We had this code for quite a while, but we finally enabled it. This PR increase the connectivity for the DSN. I mean by that if we have known peers, we save this information in some local database, and on next restart, we could reuse it and connect to known peers with their addresses and to maintain our network more connected than it could be otherwise. Also, we introduced some here, yes, some limit for connection peer-peer. So we set to connection peer-peer. And also we limited pending connections for the DSN. All these connection limit PRs should result that each peer will have less incoming connections overall. So previously it could be over several thousand pending connections and several hundreds established connections. Now it will be much less of that. We also introduced as a test as a test experiment quick transport support for DSN. I tested it locally; it should work. However, we need to adjust our stance in order to for us to be able to connect using quick transport. We have some issue with DSN that some routers, our testers with routers, with consumer routers, reported some troubles with local network. It probably could solve this. These several PRs like connection limits and quick transport could probably solve this issue. This week I will continue working with DSN tweaks. Probably the most important one is unresponsive port. If we fix that, I will go back to the custom protocol for announcing our providers because we need to get back to the main fork of the Rust P2P. That's it.
Yeah, actually, many of these pull requests actually already fixed the problem for the most part. Jeremy didn't have many issues. I see a lot of improvements on my side, so I think it helps. And users also reported.
Could you estimate your state, your change of state, Nazar?
Well, my computer has a lot of different connections, not just Subspace software, but number of states decreased like 3x.
Okay.
From what it was.
Then it
and
helped.
Also everything is like much lighter. So I do see a lot of change. And also it wasn't like there wasn't some cap of connections. it was just like growing, growing, growing. So like 1.2, 1.3 million is when I stopped, and I have 400,000 right now.
Oh, that's an
So
improvement.
yeah,
Thanks.
yeah, for sure.
More anecdotally, I'm not having call problems, and my children aren't complaining about streaming issues on our Netflix. So
Okay, I'm glad for your family, Jeremy.
Yeah, users also reported that it got better in the recent snapshot. So I think we can kind of consider it fixed, but there are still improvements to be had for sure.
I do have a question about the quick transport. What's the goal of the experiment on that?
It's kind of
Just to see if,
improvement. It's a major improvement of the transport protocol level. It's currently in alpha state in Rust P2P as well, but they didn't have any pending issues, so we could try it as well. It simplifies the stack. It should be faster, but it has some
It can be
other
faster.
issues.
It's not faster yet necessarily.
It has also improvements in connectivity level. For example, bypassing the NAT should be much more effective, probably 3 times as effective as using Rust TCP. But it has its own issues. I noticed several warnings when I tested it locally. It was once in 5 times. It's not repeatable for me. So we need to test it when we finally applied.
Yeah, there are also some strange like architectural decisions in Quick. When you're using TCP, you just have TCP as transport, and then you need to add multiplexer on top, which is YAMOX, which is not ideal. And then you have to add encryption on top of that, which is noise framework in this case. So there are like a lot of layers that are composed together to form the actual connectivity. And with Quick, you have UDP, and on top of UDP, Quick offers you streams, back pressures, multiplexing, all of that kind of stuff. It also brings TLS encryption with it. So you kind of collapse all of those layers into one protocol, which is much easier to deal with, but it is not as composable with other things.
Yes,
So it's an
I think
interesting thing.
yes.
Yeah.
I just wanted to add to your speech that it's that you said that all the stack is just merged into one protocol. It makes the connection faster because it lets less handshakes.
Yeah. Well, with TCP, it was also not that many round trips. We are using like something lazy version of the protocol, and it also allows you to have almost like one round trip. With Quick, you can actually have 0 round trips. You can like send data right away if you have some preliminary information. Yeah, basically, this edition, it doesn't enable Quick as a default protocol. It's just the protocol that Node supports. So if someone opts in into the Quick, they will be at least able to communicate very quick. Otherwise, you don't have anyone to connect to at all.
got it.
I think the
Yes,
next
we need
protocol
to
will be WebRTC actually, so you will be able to connect to our nodes from the browser, like browser to server. And in the future, it will be browser to browser as well, but that's like a next step.
yes, in order to enable Quick, we need to change running parameters for them for our Bootstrap nodes at the very least.
Well, not necessarily Bootstrap nodes. You just need to have a CLI flag for you to start node of Armor with Quick as higher priority protocol over TCP.
Yes, but you
Bootstrap nodes
won't
just need
get
to be
any
upgraded.
connections if you start only on Quick and no other nodes will support it.
Okay. Well, basically, we are starting experimenting with Quick, and we'll see where it goes.
Yep.
So just so I understand, Nazar, you said you could have it where it gives priority to Quick, but it would still back to
Yes,
TCP if
basically, when you
okay.
configure the peer-to-peer, you have ability to provide multiple protocols, and you have like the ordering. So the first one that succeeds basically is your best protocol, and we have TCP as the first one still, but we have technically support for Quick on the main branch.
So if
And
people
that's
started saying they would willing to use
Yeah,
Quick,
if
then if there's
some
more,
node starts and it only supports Quick and nothing else, it will at least be able to connect to someone.
okay. Cool.
So does it
Yeah.
mean like we no longer if we have Quick, we won't be using YAMX on TCP?
We are
yes,
using YAMX on TCP, but we are not using YAMX on Quick.
yes, this is correct. Nazar said yes.
Yeah, and WebRTC is like its own animal. It also has encryption that You cannot bypass basically according to the standard, but it doesn't have multiplexing to the same degree. It's weird. Okay, I think enough on this topic. Rahul, what were your updates?
So I have a PR out for the alternate block relay path, waiting for a few comments. And last week I spent more time testing the changes. The main thing was like I was seeing like increased occurrence of like errors where imports were failing and other voting errors and so on. So I spent like 3-4 days just chasing that. So it turns out like it happens when we see rearcs followed by pruning of the trees. So that causes all these errors basically. And I did a baseline with the main. There also we see a lot of rearcs happening, almost same amount of rearcs happening. So the main, my current hunch is that, if you look at the substrates sync protocol, they have a lot of logic inbuilt to avoid downloading blocks if necessary. For example, based on the current best hash and finalized hash, let's say a peer advertises a block, they don't basically download it. But since we are doing it from scratch, we don't have all those smarts inbuilt into our implementation. So we blindly just try to download everything that is advertised. That is causing this problem, is my current hunch. I'm doing some more experiments to verify that, but I think that is my current thinking. So because they have a very evolved way of downloading things, they have a lot of logic inbuilt. We are missing all that stuff because we are not using, we are completely bypassing that path. So I want to maybe reopen the discussion this week based on my findings about like the long-term path. Should we continue this, or should we go back to like proposal 2? Remember, the proposal 2 was basically we just replaced the block handler with a more modular block request handler, where we can just plug in our own implementation of the protocol. I think that would be more ideal because we will be reusing all the existing logic inbuilt into Substrate. Otherwise, last week, while I was debugging this, I found it was pretty complex. There are a lot of layers involved, for example, DB and so on. So it will be nice if you can just reuse things as is in Substrate, so that we don't run into all these new issues that we are seeing. So that was the main thing from my side. Also, I have the patch for the upstream metrics ready to go. I should send it out this week. And right now, this PR, the feature is like flag disabled. So I want to discuss with Nazar and others how to go forward. Like I would like to get this into the testnet with the flag enabled while I start working on the compact block implementation.
I see. Have you changed the confirmation depth to 5?
No, I have left it as is for now. Because
that was the issue, the reason why you had those errors.
Yeah, but thing is, right, I wanted to keep it at 1 so that I can debug these problems. These problems happen more easily if I set it to 1.
It just doesn't make sense to test it with 1, because with 1 you essentially disable support for forks. That's what you get.
Yeah, but thing is, right,
and if you start to farmers locally and the solution range is such that you have one piece configured, but you have many more actually plotted, and you have 2 farmers producing at the same time, you will essentially produce most of the time block or vote on both of the farmers. So you will get a fork no matter what.
Yeah,
and
but
with
thing
just
is, right,
one, you quickly diverge.
You're right. Thing is, right, if you want to do apple-to-apple comparison, and where we just set it to 1 on main, then we won't see as many errors, right? I want to understand why we see so many errors with the new path with the depth set to 1. That's why I'm basically testing with k equal to 1. So
well, regardless, we need to set k to 5 because we
yeah,
discovered that it's not correct to set it to 1, which is just too optimistic.
Yeah. So I think that should be probably a separate. I'll make a separate PR for that. In testnet, we can set it to 5. But basically setting it to one makes this
No, in production it's already 100. It's just for local testing that it was
local
set to
testing.
1.
Yeah. But I want to. I was trying to understand why we see so many errors in this new path. But that is a problem. I think basically we are missing all the logic that is already inbuilt in Substrate. So it'll be ideal if you can reuse all that stuff. Like for example, all the announcement validation and other state machine that Substrate already keeps. But yeah, I'll maybe open a discussion for that separately.
To just touch on real quick to remember proposal 2, did that also require an upstream change to Substrate to allow for that?
Yeah, so that would be like a two-step process. First, we change Substrate to make the block handler more modular. So when the network is created, you say use this particular protocol, and that would be the default protocol in upstream. But when we build our network, when Subspace service is created, we'll say instead use our protocol. So essentially, there's no change in the upstream.
Were they open to this? Or because I know they weren't open to some of the proposals we gave.
Yeah, so
They
they
didn't
kind
see
of
value in that from what I remember.
they kind of dropped the ball on that. We'll need to kind of push it if you want to do that. But I think that would be the ideal situation in my mind. That way we won't be missing out all the logic existing in Substrate. Because if we have to reinvent all that stuff, right, it will be like a substantial effort.
Well, I think it's easier for us in the short term, but in the long run, it will not be the solution we are going with because the plan is to actually drop the other networking stack, which is Substrate's networking stack anyway. So one way or the other, we will have to either re-implement all of this anyway. So we better start early, I guess, or we will have to write an adapter such that our networking stack can pretend to be Substrate stack. So we'll not only bring all of the stuff that they have, we'll also translate that into our layer, which will be even more complex, which I'm not sure we want to actually go with that. I would rather replace the whole thing. But that would be like another way to do it potentially.
So do you have like a timeline for that when you say we want to use replace their networking stack with our stack, right? Is there a timeline for that?
I don't think there is, and it is a little bit open-ended kind of question. Just like with consensus I'm working on, I have to have all of the primitives that I can assemble to consensus. We are doing the same basically with networking stack. We are still tuning, improving things. We still need to add some components to it. And once it's solid and we have verified that it at least works for the use cases that are outside of the blockchain itself, for the farmer side, then we can kind of adapt it to the other use cases. So that's why it's kind of, we have to do some research, what we want to do, how we want to do. We may not do it the same exact way that Substrate does it because of the assumptions they have with finality and validator set and other things.
Okay. So apart from that, I've been having some issues with the tool chain on macOS. A lot of things are broken. I'm trying to get it working again. It suddenly started working last night for me for no reason. So I'm trying to.
Yeah, the change recently was that there was a Rust KZG integration merged recently into the main branch, and that brings the BLST library as a dependency, which is written in C and has an adapter into Rust. And that one builds with C compiler a C library. And I think when you install the LLVM, that new version you are talking about might have that problem that the Rust discussion is about. So if you upgrade it to newer version, if it exists, or downgrade it to something like LLVM 16, it may fix it. And it's important to know for us because when we switch to Gemini 3D, we might have the same problem when we are building executables in CI.
The thing is, I did make that fix like 2 days back when I synced with latest main, and that started working. I basically upgraded to the new LLVM and Clang and everything. But but yesterday it stopped working for some reason. So I don't know why. I'm trying to figure
Yeah,
out.
I think it might have been that we just merged it 2 days ago.
I'll update what I find. So yeah, that's it from me.
Okay, any other questions to Rahul? Okay, let me share my screen and share what I was doing. I took some time last week to focus more on the code changes. Over the last 2 weeks, there were 2 pull requests with ParityDB. This first one was supposed to fix some issues, but it seemed like we've got actually more issues. But then there was another release which fixed some of those. Haven't seen any new crashes reported, but we will see. With this, it was basically a release which was saying it fixes some corruptions. And I was like, that makes sense to upgrade. But then we actually started seeing some crashes which we didn't see before. So yeah. Then there was a basic proof of space implementation. I think I have shared Chia fork on the previous call 2 weeks ago. But basically, we have a simple interface in here. You have a seed you can provide, which is just 32 bytes. You can create a table. That table hypothetically contains some solutions. You can try to probe different indices, and then you might get a quality. Quality means that there is some solution with that over there. And quality is just another like set of bytes that we can use. And we can use that for plotting. And then when we actually need to prove something, we can generate a proof with that quality. It's abstracted away such that you cannot generate proof for qualities that don't exist. Then you get a proof, and that proof can be used in the consensus. And then once you get the proof, you can actually take seed challenge index and proof to verify it. And all of this calls basically into C++ layer, which works completely in memory. It's very small change here, just 200 lines, but there is a lot of stuff in Chia fork. So if you want to look into that more detail, you can check there. Any questions about this one?
You say basic implementation, does that mean there's more to come, or?
I think there are a lot of optimizations we can do. And also we are kind of using the whole Chia proof of space as a primitive. And that means there are basically 4 stages. There is a forward propagation stage when this table is built. Then there is backward propagation when they go from the last table back to the first one, and they see which kind of values are not used at all because it forms like a tree. So if something is not referenced, they can delete it. And then they have 2 more stages to actually compress the data even further. So they have the smallest possible space used to store the data. In our case, it doesn't matter. So what we can do, we can save a lot of resources because we don't persist this table. We can just take the first stage and we can drop everything else, saving, I don't remember, like 1/3 of the computation or something like that. And also verification will probably be easier. But technically, this is already like sufficient to get the protocol working. Those will be optimizations in the future. Maybe Daria can share a little bit more about that. Okay. Then I was looking at the way we are dealing with pieces, sectors, segments, and everything like that, and I didn't quite like it because what I needed to do in the archiving, that's where it was leading to. Actually, there was a lot of like manipulations with different parts of the pieces, and we generate commitments and everything. So I did some refactoring. This is the first attempt. It did abstract away some things, but it wasn't quite nice to use. But then there was another pull request which kind of unified it further, which I can show, that basically brings a few data structures to us. It's all in the Subspace core primitives in new module called pieces. It is quite large. I can just probably open it separately. So what we have here, we have notion of record, and we have record witness, and we will have record commitment in the other pull request. Then there is a piece, which is basically the same as before, but it's no longer just bytes. It's this heap allocated data structure, and that data structure is a separate type, which has methods to like reference it as bytes or as some other thing. And we can also split it into record and witness, which is just references original memory without any reallocation, anything like that efficiently. We can also split it into mutable pieces, so we can like write a record, or we can extend a witness if we just generated a blank one initially. And there are also methods for convenience to like address individual pieces separately if you want to. The flat pieces data structure is just basically efficient way to allocate a whole bunch of pieces instead of doing many individual allocations. Was initially just vector of bytes. Now it's a vector of these things. So that allows us to also reference this meaningfully as a set of pieces, and individually those pieces still reference records and witnesses and commitments and everything like that. If you want, you can still reference it as bytes, and you can manipulate it that way. And in the future pull request, there is also many more things. I will show it later. So this is basically a refactoring to bring those into the code base, and also refactor some things to make use of them. It is quite nice. Ivan also liked it and suggested some more improvements that we did. The drawback is we are using some unsafe. I checked the documentation and everything. It should be correct. I also sent to the auditors, to Azure Labs, to take a look at that. But it saves us a lot of reallocation, a lot of things. We can just do things very efficiently, which I think is a good thing. Any questions about this?
Did you try it separately to just check for memory leak?
Not really. I was running some things locally, haven't seen any problems. And these are the kind of changes, like canonical ways to do it. So for instance, let me show one example. For instance, in here, what we are doing, we are taking the piece, which we know the size of, and we know the size is composed from record and witness, at least in this revision. So we slice it into two parts. We have two memory slices, and then those memory slices are just bytes, but we can try to reinterpret them with Safe API into reference not just bytes, but to array of the same size of bytes. That's fine. And we make expect because we know that the size is correct. We just did it, right? So it's obviously correct. And then we are doing transmute, which is unsafe operation. But at the same time, we are transmuting that into record. And if you check what the record is at the very top, the record is just an array. And since this data structure is transparent, which means it is guaranteed to have the same layout as internal data structure, this transmute should also be correct. So those are like static assumptions that you can verify just by reading the code. You don't need to like run it necessarily.
Okay, makes sense. So it's not related to that PR that fixes piece decoding.
It is, actually.
Oh, okay.
I will show it later. It's not memory leak, it's just Stack Overflow.
Yeah, also like lifetimes here are bounded. Like we split mute, it takes like mute self, right? So here there is an implicit lifetime, which is the same as for the record and record witness.
Exactly. So everything is still tied with lifetimes and compiler guarantees and everything. We are not throwing away any existing assumptions. We're essentially still dealing with memory slices. We just glorify them into new types, which are like two new types of the same size and not the same type. So it doesn't compile if you use it incorrectly. That's the primary reason.
It is also weird that like Rust doesn't support like not transmuting, I guess, but like casting to like same types if they like use the same representation.
There is a crate called Safe Transmute, I believe, which supports some types of casting. So you can take something like U64 and cast it into 4 U8s because it's obviously still valid invariant. Just compiler doesn't give you, or like standard library doesn't give you tools yet. But there are many conversations about the topic. That would be nice.
So I guess you could also achieve this by using like raw pointers, right?
Say again?
No, the thing that you just showed. I think you could also achieve that by using raw pointers, right?
No, raw pointers are a different thing, quite a bit different. For one, they don't capture any lifetime information. In this case, we are not using raw pointers at all. We just say that this mutable reference to an array is actually not array, but mutable reference to a data type, which guarantees to be the same as array. Like it's essentially the same thing for compiler. But for us developers and for compiler, when we compose things, it will complain if you're using types incorrectly, just like any other type. So we are still a few steps from the raw pointer at this point.
let's say even more.
Yeah. Okay, so this is an interesting thing, suggestion from one of our ambassadors. The ambassador was basically building custom builds for users. There are these somewhat official standards on Wikipedia where there was an old like microprocessor architecture x86-64, the initial one which had some set of instructions, and then Intel and AMD were building different instructions on top of that. But if the compiler is targeting these old processors, it is not able to use those instructions. And basically, what compilers did, they created these like presets, which are like pseudo architectures that include some of those instructions. So if you look at the version 2 here, you can actually see there are a few more instructions you can use. And then if you opt into version 3, you can use some vector instructions on top of that, which are nice. So what we are doing instead today, we are basically assuming that no one will be running processors from like 2006 with Subspace. And we have V8, V2, which is from 2009 approximately, and V3, which is from 2015 or 16, something like that. So if you use those new processors, you can actually take advantage of that, and it will be faster up to 2x according to reports in some cases. For the rest, they can still build it for the original one. I just don't see the value of not using all of those potential improvements for our community. And the same things were applied, from what I know, to the CLI, but not for Windows just yet. And if you go to the releases, it actually explains what it is, because it's not clear for most people. We basically explained that if you have this processor, this is what you should probably use. But there could be some older VM which doesn't support some of the instructions used here, so it will crash, but it's up to you. Okay.
How
Um,
are we going to communicate that ongoing? Will we just leave that note there? Or
Basically, yes. Currently, documentation just points people to version 3, and no one complains so far, but
okay.
we should
But
explain this somehow.
by the way, I experienced about twice this syncing speed, so that was great with V3.
Yeah. So the next one, basically the challenge is that when we want to switch to the new KZG library, we also want to change the maximum supported number of things we can process with KZG. So like we can commit to more things. However, that requires much bigger public parameters like trusted setup values. And that means that all of that stuff has to be included in the runtime, or at least it had to be in the original version, because we are bumping from about half a kilobyte or half a megabyte to 4.5 megabytes of data. And it clearly is not sustainable, and we will not be able to do even a runtime upgrade, because that alone will be bigger than the number of data we can put into the block. So the refactoring and basically extracted away the interface in the runtime that the runtime now uses to refresh to verify solutions with the host instead of doing that in the runtime. It is faster generally, and it also saves us from including those public parameters in the runtime, because runtime doesn't do it anymore. Before we can actually do that, there's a need to move this KZG parameter out of the verification function. Where is it? Subspace verification. We basically had 3 parameters. Now we have 4. Why is because we can use these parameters still as is in the runtime interface. And this KZG will just be gone because it's on the host completely. So this is a simple refactoring pull request. And then after that pull request, there was a pull request with the actual runtime verification. And my internet is not very, very reliable right now. Yeah, it will load eventually. Why now?
Is it a GitHub issue, or is it your?
It might be a GitHub issue. It might be my issue. I'm not sure yet. Status GitHub.
And we see you without interruptions.
Yeah. Yeah. Okay. Finally. All right. So the here important thing is that the pilot subspace is no longer calling the function for solution verification directly. Or I can show it here. It's not importing function from the subspace verification anymore. It is instead calling function from the consensus module in the SP consensus subspace. And that one instead does the runtime API call. It's kind of a little bit inconvenient the way it works in Substrate. I cannot find it. Okay. Basically, what you do is you define a macro runtime interface on a trait of all things, and it will generate a whole bunch of code. And there will be a data structure, and there will be a module called consensus. And then this verified solution will become a module, not a module, a function in that namespace or like module. I think the reason is that there are no macros on modules yet in Rust. When it becomes a thing, it will be more clear. But then we also need to reference some things from here, and that's what we do. We are having a thing called externalities in a Substrate, which basically allows you to define kind of an extension in the blockchain. And then if you define something like self or mute self here, in mute self is required to use extensions, you can call into the blockchain basically and say, give me this KZG extension if it exists. And we assume that it exists, otherwise nothing will work. And then we can call the same function we had before. We can take the 3 parameters that runtime provide us, and we can also use KZG on top of that to do the actual verification. And the way we define extension is we have basically a data structure, KZG extension. We can have some data in it, and we wrap it with this macro, another macro. And then for standard environment, we are able to construct it. And the other ones are just such that we can pass the parameters to this function back and forth through the runtime. There are some requirements for that. And then when we are doing the actual stuff in the node itself, we just need to take those things and compose into the extension factory. And then with that extension factory, we can create a set of extensions and push the KZG extension into it that has KZG itself as a parameter. And then once we have this factory, we can set that factory on our node client from Substrate point of view as a thing that provides extensions. And we just have one extension. That's why it looks kind of awkward that we have a factory to produce one value, but that's kind of how you do it. And if we have more runtime parameters, runtime interfaces, we can add them later. And for the testing environments, we also had to do kind of the same thing, but it's kind of trivial. I hope it makes sense why the previous pull requests and this one were necessary. Okay. Then with those things, I was finally able to create the transition pull request from the old KZG implementation we had to Rust KZG and bump those number of values supported. It's kind of like I was working at the same on all of these things at the same time when I was discovering different edge cases. That's why a serious pull requests. That's what I basically ask you to do when I'm saying that this pull request contains too much, or it's like in awkward order or something like that. I was like splitting those things and refactoring them such that they are presented clearly as one thing building on top of the other thing. The main change here is that the underlying library is different, but the API is basically the same. So when we are going into Subspace core primitives and we are looking at the KZG library, it is importing a different library, but then if we are going into the KZG itself, it's basically types that change. Everything else is more or less the same. And the interface here, the constructor is different, but otherwise we still have a method to create polynomial. The error is different because of the underlying library. This is our wrapper type, so it's still the same, even though the bytes underneath it are maybe different. We still can commit to the polynomial, we can create a witness, and then we can, of course, verify the witness. But otherwise, it's still more or less the same interface. We do still have that huge public parameters file, though. I think that's the biggest thing to talk about here. Yeah, I think that's as much as I want to say about it. Any questions about here? Just like with Chia, there were a few pull requests and different things that we were doing upstream. There are still some things pending, like in BLST. I'm still having a hard time to convince to merge this pull request. That's why we are using our fork of Rust KCG, which uses that fork of the BLST. So we have to kind of fork two libraries. But hopefully at some point they will support Noisity in some capacity, and then we'll be able to use the upstream version. But for now, we have a fork. Okay. And then we have a new abstraction for the scalar. Basically, we had the old one, which was built on the old library, but we want to use KZG and scalar types for both erasure coding and for the KZG itself. So we had to unify it. Basically, we had the scalar before. It is refactored to be old scalar if you go through commits. And then below that, not old, scalar legacy. And then we have the new scalar as well. I don't quite see where it is. I think it's a separate module. Core primitives. Lib. I think it's in KZG. No. It's in crypto. Basically, scalar is our abstraction for the underlying library, and just like this. But it allows us to have not just generic thing, but the thing we care about, and also a bunch of different conversions and serialization with Serde and serialization with the scale codec, all of the things that we need. As usual, we can still convert it to and from different data types. We have two essential types. One is array with full bytes, which is 32 bytes, but it can also only hold to 54 bits of useful information. And we also have save bytes, which is 31 bytes, which is convenient for different slicing operations. And basically, we are using these types in all other places. And we also have some transmuting that allows us to interpret this thing as the underlying type, so that we don't have to reallocate when we are calling cryptographic functions in the library. But otherwise, we can still deal with the scalar type that we care about. So there are a whole bunch of those transformations. We can interpret things as slices, as vectors, which are a little bit more involved. And we can also use options, slices of options and slices of vectors of options, which are useful for erasure coding. And I think erasure coding, yes, the Subspace erasure coding library that we introduced before actually uses those types already, just like KZG does. So there is already kind of bridge between them. Any questions about this one? I also sent these unsaves to auditors. Okay. Then there were some minor tweaks. And then this unified, improved unified piece abstraction, that's what I was talking about. And that's where the problem actually was introduced. Essentially, even more refactoring. Now we have more unified types because before we had record ref, not record ref. There was record ref mute, and stuff like that. Now it's clearer. I'm not sure if I showed this pull request before. I think I did. I think I showed it. Yeah, I showed the latest one. So let me go into the fix for Stack Overflow then. Essentially, there is a bug in Rust. If we simplify to that, there is a bug when you have an array that is boxed, essentially something like this. You have an array and a big array, and then it's boxed. So you want to use heap instead of stack, otherwise it will be Stack Overflow. But this naive usage just crashes because it first tries to allocate this on the stack, and then it will try to move it to the heap. Doesn't make sense, but that's the way it is right now.
I mean, it kind of does, but
Yes.
Like it's a semantic thing, like in terms of the language. Like it does make sense because like there is a box, how to say, syntactic word.
But that's not what user means. Like if you do the same thing with the vector, it doesn't crash.
I mean, like you could have used box keyword instead of the box new. Like
almost. You almost
unstable,
could,
though.
but it is removed actually as of last week from ROS 9.
Really? Whoa.
Yes. That's why
That's
people
up.
complain at the bottom of this issue even more, because it was a workaround before, but now it's gone. It is even a bigger problem. In our case, I wasn't doing like that. I was just calling default, but even that default implementation was still causing the same issue. And why it was a problem for us is actually not that even. It was the scale codec. Basically, when scale codec works, it tries to locate it somewhere internally. So what I had to do instead, I had to delete the default decode derive, and I had to try to decode it as a vector that doesn't have vector prefix, so I give it the size explicitly, and then I was doing unsafe to reinterpret that, or like the heap part of it as an array of the same size, so I can actually get the value that I care about. It's annoying. There is an issue in Substrate. When they at least fix the derive, it will be easier. There is a very simple reproduction here, kind of the same as in the Rust issue. But these are the kinds of things you hit when you go deep. And this is unfortunately open for quite some time, so not much hope for it to be fixed next week, but at least we know what it is, and we'll be careful going forward. The last one I should comment on briefly is this. This pull request is a few-step process described here that essentially converts our archiving process to the consensus version 2.3 spec. And we had some discussions with Daria to actually change the spec a little bit to match what we can do. And it works. And the rest of the consensus is still version 2.2, but the archiving is 2.3. We already have commitments. We already commit to, we already create witness for commitment instead of hash of the piece and stuff like that. So you can go into details here, but essentially we are refactoring a lot of stuff here. And there are even more data structures of the same kind that we mentioned before that make it possible. One particular one that I want to mention is raw record. Essentially, when you create archived segment of archived history, we have records, and previously we didn't really distinguish them in a specific way, but now we have to. And because of that, we actually introduce here a new data type, which is raw record, which contains save bytes, but the regular record will contain the full record, which is non-save bytes. And then we also have record the history segment as a data structure. We are almost at time, so I will probably stop here. Any questions about this one? Okay, if anyone has any questions about this, I'm happy to have like a call or discussion or whatever, because this is important stuff. This is something everyone needs to understand. Otherwise, we'll not be able to maintain it. And this is a little bit, this is the wrong name of the pull request. It's an optimization for this pull request, where we are ratio coding commitments instead of creating commitments when we already have half of them. Okay, with that, I think those are all my updates, and I hope, Daria, will be enough time for you to describe what you were working on.
I mean, from the core protocol side, the main thing was supporting all of those changes to archiving and ratio coding and so on that you were making. And sorry, I'm having a baby emergency.
Okay, yeah, it was great support from your side on various different things I was discovering, like whether we can do this or this is not possible, let's change it to this. For instance, one of the things we will change in this specification, which is not reflected yet, I think, is that the ratio coding we are using, it is producing interleaved value, which means like the first index is the source data, then parity, then source, then parity, instead of first half source and second half parity. So that is something we have discovered. So it doesn't make sense to translate it back and forth all the time. It's just not efficient from like computational point of view. So we have to change that in this specification. This is like one of the biggest changes here. But otherwise, thanks for support. Had a lot of questions. All of them were answered. No blockers so far.
Why did we change the library in the first place?
The previous library for ratio coding was not using KZG primitives. So we're not able to use some of the overlapping kind of synergic properties. For instance, in this latest pull request, we are ratio coding commitments, which means we have source, we have parity records. We create commitments just for source, and we not create for parity, we just ratio code it, which saves a lot of computation. So those like properties are not possible if you are using completely different primitives with a completely different crypto for ratio coding and KZG. But since we are using the same, it plays out nicely in our consensus. It's like fundamental change.
Okay, thank you.
So the magical moon math kind of stuff just happens to work that way. All right, I think that's all the updates we have so far. And we'll see everyone in 2 weeks with even more updates on the core protocol. Thanks.